So today we're going to be looking at the general definition of an angle. So let's think about mathematically what we think about when we think of an angle. So we're going to have some axes. It's x, this is the y, and we've got a point 0 to p, some point 0 and this is p. Okay, so to measure the angle, we measure the rotation of a line, so this is our line, OP, about a fixed point, so this is a fixed point, we keep it at the centre O, and we measure in the x, from the x positive direction, so we take it from here and we go in the anti-clockwise direction, theta. So an anti-clockwise rotation is taken as positive, and conversely a clockwise rotation is taken as negative. So this, if I'm going around this way, it's positive. If I started here and went that way, for example, here, let's call this Q, this would be minus theta. However, you could have, I'll just draw it in here actually, let's a different colour. So if I had, say, this angle here and it went this way, that's going to be positive. But if I took some angle from here, I'm going to draw the angle coming over here. But if I went this way round, so the arrow here, this would be minus theta because it's in the clockwise direction. I'm going to just draw another. I'm going to draw a simpler one again because I've made it all messy. So let's go back just to a wee simple point P of angle theta. Now, in the Cartesian plane, so Cartesian means the coordinate system that we use with x, y, and you can actually have a three-dimensional Cartesian plane in the z direction as well. But for the x, y Cartesian plane, we have four quadrants. So this is the first quadrant. This is the second quadrant. And this is the third quadrant. And this is the fourth quadrant. We need to just be aware of this because sometimes we might need to define what quadrant an angle is in. So let's look at some examples. We're going to draw a diagram. So we want to draw a diagram showing the quadrant of line OP for the following. And we want to find the angle OP makes with the x-axis. So firstly we're going to do 120 degrees. So let's draw our x and our y. Now from here to here is 180. So let's think 180 minus 120 must be 60 degrees. So P O 120 because it's positive, and this here must be 60. So it's an acute angle made with x-axis equals 60 degrees. Now we want theta equal, no, not theta. We're going to have 430 degrees. Now that's more than 360, so we need to think about this. There's x, this is y. So if we've got our point P, our line goes right round back to the beginning. So that's 360. So we need to think, what is 430 minus 360? Well, it's going to be equal to 70. So it comes here and then it goes back a lot. It's actually another rotation, but stops. That's P, that's O, with this angle theta equal to 70 degrees. So it's an acute angle of theta equals to 70 degrees with the x-axis, and it's in the first quadrant. Now we're going to do a couple of dealing with radians. So we're going to think 3 pi over 4. So what does that mean? So let's think, what is pi? Well, pi is 180. So 2 pi must be 90. And so 3 pi, if we were to split this into quarters, 1 quarter, 2 quarters is a half, is, or 2 quarters is going to be up here, and 3 quarters is going to be here. So this here is 3 pi over 4, and therefore this must be pi over 4. So it's acute angle made with the x-axis equal to pi over 4. And now we're going to do 2 pi over 3 is a clockwise rotation. So we've been defined the direction. So clockwise must be this way round. So again, think from here to here is 180. So we split this into thirds because it's thirds. 1/3, and this is going to be 2/3. So from here to here we have 2 pi over 3. So there must be one more third here. So we have an acute angle made with x-axis equal to pi over 3. Now, something just to be quickly noted, the acute angle made with the x-axis is sometimes called the basic angle, or the reference angle. So that's just something to take note of. So I hope that helps.